doing that along the way too, and how we control the general purpose input output on the Pi. And then we'll dive into a couple of NuGet packages that help us with that as well. And then we'll talk about Blazor and SignalR and some final demos. I should change that to an S really, because there's more than one of those at the end now. And if we get some time, some Q&A. So .NET 5, as you probably know, is a cross-platform and open source, and we can target many different things from desktop and AI through mobile and IoT, which is nice for us. We've got some nice new features in C#9 as well, where we get things like records and init-only properties, where you start out with something like that and you just get down to 2 lines, which is nice. Pattern matching on types, which is a pretty cool addition. Top-level programs, where we would normally have, even a reasonably basic-looking Hello World application can go down to 2 lines, which is great for people that are just starting out, students in the subject. And we've got a new JSON library, which makes James Newton King a little bit unhappy, of course. But, they gave him a job at Microsoft, so I don't think he's that unhappy. This came out here at Build last year, actually, this slide, at that Journey to One .NET. And if you've not watched that, go and watch it. The link's at the bottom of the page there. But what I wanted to call out was this 40% of new .NET programmers are students, which I thought was a cool stat. Because normally the mainstay of student programming would be either just plain C or Python these days. So it's good to see .NET making its way into student establishments like that. So moving on, getting .NET installed on a Raspberry Pi, Microsoft hasn't given us an easy way of doing that. And there would normally be quite a few steps. And if you're not 100% au fait with Linux, then some of them can be a little bit arduous and some of them can end you up in trouble. So I've created a single line install script. And you can sort of see on the GIF there the amount of different steps that it goes through, but essentially it downloads the binaries for .NET and ASP.NET, and then it'll extract all of those to a location on the hard drive, the SD card in this case, and then it does some linking together, and then at the end of that, then you're pretty much up and running. You can run a .NET --info and you're happy. Just do a reboot after you've done it, but it really does make life quite easy. So once you've done that, then you can get a basic console app up and running. Now, I've got Raspberry Pi sitting here, which you'll see a little bit of when I show you the camera feed in a bit. And I've got a GitHub repo that I've pulled down on this. I'm not going to do any programming at all in this talk. I'm just going to step through branches of code and explain the code as I go along. I'm not nearly brave enough to try and code all of this live. So, obviously, the first thing you should check once you've got .NET installed is that you can run .NET-info. You can see I've got a few SDKs here, but I've got what I think is the latest one here, 5.8.202 installed here. So if you need a new version, you just run that same single line install script again and you're off and running. Obviously, I could do a .NET new console at this point, but actually I'm going to start with GPIO. So if I go across and move on to GPIO. So GPIO, if you don't know, that's general purpose input output, and that's the array of pins that you've got down the side of the Raspberry Pi for driving LEDs and other things and reading buttons and other things. This GPIO, that collection of bits and bobs, there's a NuGet package for that, system.device.gpio. And that supports obviously basic things like I/O, so LEDs and buttons I mentioned, but also things like serial ports, SPI and I2C, and PWM, pulse width modulation, which we'll spend a bit of time speaking about because that's how we're going to drive our robot. That NuGet package actually supports a few other boards, but I tend to just concentrate on Raspberry Pi because I know it well. It also supports Windows 10 IoT, but I don't advise anybody to use that these days. It used to be that was the only way to get anything XAML onto a Raspberry Pi, but with things like Uno platform, which we'll mention later, then you don't even need that. And I think maybe the last update to Windows 10 IoT, and I'm talking about that actual image Windows 10 IoT, I think maybe in October 2018 or something. So it's really, not advised anymore. But you can install these NuGet packages on a Raspberry Pi using the CLI, just like you would on any regular PC. So just to explain a little bit about GPIO, because we'll be looking at it in the code. There's a couple of different numbering schemes available here. There's the board numbering scheme, which are these numbers closest to the pins, and there's the BCM numbering scheme. Now, BCM's speaking about the chip, BCM driver chip for GPIO. So these are sort of more technical electrical numbering schemes here. I tend to just stick to the board numbering scheme because I can count, and I don't have to then convert from BCM to another numbering scheme. So we've got pin 1's the square pin in the top left, and then next to that is pin 2, and then 3 and 4 and 5 and 6. And it's as easy as that. So we'll see this numbering scheme in a second, but it's important to call that out. I've got a basic circuit. Actually, this is part of the basic circuit that I've got. But this is what is normally hello world, if you will, for any IoT application, is flashing an LED and reading a button. So, of course, we do that. We must. So I've got one side of a resistor, which is connected through to an LED on pin 10. And then I've got a button connected to pin 26. And we'll come back to this, this circuit in a little bit, because it will be important. So let's have a look at how that works. So if I flick across to here, I've actually got, if I open this in my in VS Code, so let's just hide that and make this bigger. That's probably too big. There you are. Shout if anything is too small or whatever. But what we've got here is we've pulled in that system.device.gpio NuGet package. So that's what's going to be doing a lot of the heavy lifting of what we are going to be using all the way through all of these demos. And I've got threading because I'm going to use a delay. Next is this right line hello world, and you'll recognize that from any console, this new console, .NET new console that you'll run, you'll just get that. But I'll leave it in there because, as you'll see in the next demo, if your IoT application does nothing essentially until you do something to it, you don't know when it's actually started. So you could be sitting there waiting for a button to be pressed, but you don't know if it's waiting for the button yet or if it's just compiling and starting up. So I'll leave that in there to know that. I mean, I could have put anything, could have put application started, but hello world's as good as anything. So I'll just leave that in there so I know where I am. Then next is this GPIO controller, and this is what we're going to be interfacing to all of those pins on the Raspberry Pi with. And you can see we've passed in that pin numbering scheme of board that I mentioned earlier. I could have put BCM there just as easily, but we'll stick with board because it just makes things easier. Then I've got a couple of variables. I've got the pin, which is pin 10. And if I go back to the circuit, you can see that's what I've got one side of my LED connected to. And then I've got this light time because we're going to turn the LED on and then have a delay and then turn the LED back off and have a delay and then go around in a loop, which is what we're doing here. So on line 25, we're taking the controller that we're opening the pin on here. So here we've got controller.open pin, passing the pin until it's an output. So not particularly complicated, but we'll come back to the button version of this in a bit. And in this loop, we then write a value to our pin here of high. So we've opened it as an output and we write a value of high, which will turn the LED on. And then we wait for our 300 milliseconds and then we write a value of low and then wait for 300 milliseconds. So this isn't particularly complicated programming here, but it's good to get a good grounding just in how that works. And then just a bit of tidying up to close the pin at the end. So I've dialed in, this is putty that I'm using here, by the way. And if I run that, .NET run, of course, you won't see anything yet. But what I have got is, if I maximize this, I've got a camera pointed at my little rig down here, which is live. So that's my hand. And there's the LED flashing. So that is what your normal hello world for IoT applications will be, flash and LED. There's no onboard LED for a Raspberry Pi, so that's why we need to do this. There is, but you can't control it. That's the power LED, and then there's a disk access, if you wish, LED after that. And you can also see the robot that we're going to be controlling later. So yeah, I'm happy with that. That appears to be working. So if I stop that code now 50% of the time it'll stop with the LED on. Oh, and it's that 50% of the time. And actually, I quite like it when it does that, because when I run the next demo, it actually tells us a little bit more about what it's doing. So making sure that's stopped as it has, I can then switch to the next branch. And by the way, this is public on GitHub, so there's a link at the end, and you can all grab this if you're interested and play along. is to your heart's content later. But the next bit we'll do is read a button. So I've not done much to the code here. It's pretty much all the same at the top. But what I've done is I've added an extra variable on pin 26 for the button. So again, that's where we've got our button, pin 26. And then I'm opening that pin and I'm passing in input pull-up here. So not just input, but input pull-up. If you notice on here, I've got no resistor anywhere in the button circuit at all. And if you know anything about electronics, the inputs on the Raspberry Pi are what's called open collector inputs. Now, what that means is that they don't actually go anywhere, so they just float. So the way that we've got that circuit connected at the moment, if I press the button, it will definitely go down to 0 volts, which is what the other ground pin here is connected to. But when it's not pressed, it's just going to be floating. Now, if you didn't have the facility to be able to specify input pull-up, what you would do is you would take a resistor and you would pull that pin to a high level so that when it's not been pressed, it's always high, so you know it's high. And when you press the button, then that'll pull it low. Now, this is an important thing to mention about that logic. So when I press it, we're going to get a low, which is going to be a 0. And if I don't press it, we're going to get a high, which is a 1. So it's going to feel a little bit backwards when we look at the code. So once I've done this open pin input pull-up, here I'm reading that button pin, and if it's false, 0, low, then I turn the LED on. So it seems a little bit backwards because it kind of feels like you'd want to turn it on when the button was pressed, and you feel like that should be a true, but it's not, because electrically the button is connected to ground on the other side. So I know some people look at that piece of code and go, huh, what's that? It's all backwards. But that's the reason why, because internally, inside the Pi, we're pulling that up when you're not pressing the button. And when you press it, it goes low to a false. And then we get high and the low on the LED. So I can run that. I'll switch back to here. Now, the good thing is I can just watch this, because when it's finished running up, then that LED should turn off. So I don't need to wait for Hello World to appear. There we go. So that's started. And now if I press the button, and I know it's quite small, but I'm assuming it's big enough on your screen, you should see the LED flashing. So that's probably one of the most expensive ways you can connect a button to an LED through a Raspberry Pi and all of the gubbins that I've got connected to it. But that's definitely where you start with Hello World. Now we've got control of outputs and we can read inputs. So we're happy at that point. That's all good. But it's not particularly interesting at that stage. So switch back to here, and the next demo will be to move the servos, but I can't do that until I've explained what I'm on about. So just to talk about device bindings now. Now, we need to use something called PWM to drive our servos, pulse width modulation, and I'll explain what that means in a bit. Now, the regular device GPIO NuGet package that we're using there, that supports PWM, which is fantastic. But to drive a servo, a little mini motor, and again, I'll explain more about that in a bit, it's a bit more complicated than just PWM. You need to get angles and frequencies and everything right. So normally you'd have to write a bunch of code, but we don't have to do that. So there's a NuGet package, this IoT.device.bindings NuGet package, and it's a whole heap of code written by other people, which is great, so we don't have to maintain it. And it supports a whole heap of peripherals that we can connect to our devices. So temperature sensors and I/O expanders and Explorer hats and Sense hats. So if you ever used a Raspberry Pi, then you get these hats, hardware attached on top. And one of them is a Sense hat, for instance. And there's a couple of those up on the space station. So when Tim Peake went up there, he took 2 Raspberry Pis with him, with 2 Sense hats on there, and kids can run experiments on the space station. Which is fantastic. It's a really great way to get kids into STEM if you can tell them that it's going to run on the space station. Never mind kids, adults, in fact. So yeah, there's probably about 50 devices that are supported in this NuGet package, and it just simplifies down all of that control code for you. All you need to do is just a little bit of setup, and you can interface directly to a bunch of devices. But one of those sections of code in that device bindings is servos. So we get some control code for that. Now, just before I talk about servos, here's the circuit that I've got. So if I zoom in a little bit, I'm using this thing called a Servo 6 board. Now, a servo, as I say, it's a little mini motor, if you will, but you can't connect that directly to your Raspberry Pi. Well, physically you can, electrically you can, but you'll likely blow up the pins on your Raspberry Pi. There's only a certain amount of current that a Raspberry Pi pin can source, as it's called, around 30 milliamps. And if you install a servo, it'll be 300 milliamps or more, maybe. And so bye-bye GPIO pin. It'll overheat inside the Pi and goodbye. So what you can do is get a little interface board, and what that's got attached to it there on the right-hand side is a battery pack. So it's going to separate out the power from the control. So what we're left with connected to the Pi are the lines to just control where we want that servo to move to. So I've got a bunch of them connected here. So on pin 25, it's just ground. Now, if I had time, I'd email the guy and tell him that his labeling on this board is a little bit duff, because when I first looked at it, I'd missed that ground because it's not in line with all the rest of the pins, and it kind of looks like pin 1 is where ground is. So I hooked it all up and it wasn't working, and then I realized what my mistake was. So that first pin's ground. So next on from that is the first channel, and it can drive 6 servos if you want. But all it's doing is just passing on your control lines out to the servos and feeding in power from the battery pack. So that's pin 35 there, which is one of the PWM ports on the Pi. And then pin 13, which is the other one. And then pin 12 is just another pin. And I'll come back to this, but there's 2 hardware, if you will, PWM ports on the Pi, which is no good if you've got 3 or more servos. So you have to do some of the control using software, and I'll come back to that in a bit. On the other side of that Servo 6 board, we've just connected up our servos. So I've got 3 at the moment, but there's a 3D printed model by Cliff Aegis in this repo that can accept 4, but the code's dead simple when you get to see it. So that's easy enough if you want to add those. The yellow pin on the left is the control pin. It's quite hard to see, but there's actually a C labeled on that pin, and then a plus and a minus, where the red wire will be the positive, which is whatever your battery pack's going to give you, and then ground on that. So it's nearly always yellow or orange, that control pin, so that'll just guide you to which you need to connect that to. So control, power, ground. Servos. So the idea with servos is, and I'm using something called 180-degree servos, is that you use PWM, so pulse width modulation, and you can change the width of a pulse to that servo and it'll move. So if I do show you like this, so if you do like a short pulse, then it'll go one way. And if you do a medium pulse, then it'll go another way. And if you do a long pulse, then it'll go the other way. And it keeps in that position by constantly giving it that pulse. So it's kind of floating in that position. So obviously you change it and you're going to get different positions on the servo. So you imagine that's 0 and that would be 90 and that would be 180, for instance. That's a simplified version of how this is working. But for all intents and purposes, that's how a servo is being moved. And with the Pi, we have, as I said, 2 hardware PWM ports. So you just tell it the frequency and the pulse width, and it just does it for you in the background. So regardless of what's happening in the operating system. That's great if you've only got 2 servos, but if you've got 3, now you're into having to maintain that exact pulse width and frequency yourself. But luckily for us, in that device bindings library, it does this for us. So we can create something called a software PWM port, and we can switch something on that tells it to be in high definition, high accuracy mode, and it works really well. It took me a while to actually figure that part out, but that works out quite nice. So servo demo, if I talk about the code here and then I'll just show you what it's doing. So I've brought in PWM and PWM drivers here, and I've also brought in servo motor. So this is coming from our system.device, which would normally be .gpio, but I'm bringing in PWM and PWM drivers. So you get that with that device.gpio or system.device library, more to the point. But servo motor, you can see, is coming from iot.device. So that's our device bindings NuGet package. Then a bit further down, we've got our ubiquitous hello world that I always bring in. Then we create a PWM channel. And again, this is using that system.device NuGet package. And I create that by passing in 3 different parameters. The first one is the chip number. There's only one chip on the Raspberry Pi, so both of these channels here will use 0 because of 0 indexing. And then you pass in the port, and there's 2 ports, so we use 0 and 1. And then we pass in a frequency. And I just leave that as it is because it works. So I don't change that. Then we create a servo motor and we pass in our PWM channel. And then we pass in the minimum and maximum pulse widths, or rather the minimum and maximum pulse widths here, and the maximum angle that your servo can go to. You can get 360-degree servos, but on a robot, it's a little bit awkward if you do that. So I'm using 180-degree servos, so I pass in 180 degrees there. And then I've created a second one of those. And then here, I'm using a software PWM channel, which this is coming from that device bindings again. And I pass in a pin number here. So instead of the chip number and the channel, I pass in a pin number, and then that same frequency. And then this true at the end here is the thing that puts it into high accuracy mode, which means it works. If you don't do that true, it'll sort of work, but it will be jittery and horrible. So this just dedicates more system resources to that particular functionality. After that, it's exactly the same. I just pass it into the servo motor and specify minimum and maximum pulse widths. I just fiddled with those to make them work. If you buy your servo and it's not getting all the way to the end, then you can change these 2 figures and possibly that one, but most likely these 2 to make that go. So minimum and maximum pulse width there. Kind of force it into one direction or the other if you remember the GIF. And then I start the servo motors up, which is nice. And then I've got a little move to angle routine down here, which just takes in a servo and an angle, and then it calls in to that servo into the right angle function and takes an angle. So just, I'm copying and pasting that code, but just later on, it just makes life a bit easier. So I tell it to move servo 1 to 70 degrees and then a 2-second wait, and then onwards servo 2, servo 3, and then backwards again on there. So it's going to do a little servo dance. So, and then at the end, I'll just stop the servo motors. So let's see what that does. I'll run that up. And while that's running, I'll have a quick look at the chat. Chat. No chat yet, so that's good. That's fine. So if I then get back to this, there we are. So it's doing a little servo dance. Not particularly complicated, but now we're driving our robot arm. I think my batteries might be running out soon as well because it's not getting all the way up when it's going up, so it's struggling a little bit, but it's doing enough. So before it runs out of batteries, I'll stop that. There we go. Now, you can't hear this, but it's actually kind of buzzing a little bit in the background because if it sits up against the servo, the last time we controlled it, it's kind of still jittering in a particular position. So sometimes you just got to give it a bit of a knock and it'll stop making that sound. So that's great. So we're controlling the robot, but it's controlling itself really. We're just telling it what to do. There's no interactivity there. And when I was sort of fiddling with all of this tech, that's where I got to. But I thought, I really want a way of interacting with that robot. So I want to be able to move it. Now, back in the time when I created this, I didn't know about things like Uno platform and stuff like that. So the only way I could think to control it was to do a web interface and SignalR. So we can talk about that now. So I chose Blazor as my flavor of ASP.NET, if you will. So Blazor is a single page app platform that essentially means we can write C# for front-end web apps, which is great. It was created by Steve Sanderson. It was a pet project of his, actually, and he demonstrated it at a Microsoft conference, and a bunch of Microsoft people saw it and went, oh, we need this. This is fantastic. So quite a few years back now, of course. So there's been quite a few iterations of that. It's all Razor in HTML, and there's a few different flavors of it, and there's more and more coming all the time. But there's 2 kind of camps. There's server-side Blazor. So as the name suggests, that just lives on the server, and you just run a really thin client on your in your browser on your machine. And funnily enough, it uses SignalR then to coordinate changes to the DOM, the document object model, in the browser. So all of the code lives on the server, and your browser just gets an update of what it should look like, essentially. And then likewise, if you move controls or whatever, then there's a little piece of JavaScript that just runs, and that coordinates that change of information back up to the server. And that's the basics of how server-side Java Blazor works. But client side is WebAssembly, which is fantastic. So this runs completely in your own browser, in if you will, a virtual machine, but it runs proper .NET. So it pulls down proper .NET DLLs, which is cool. And that's what I chose to use, was client side WebAssembly. But you can mix the two, and that's what I had to do here, because if you're going to use SignalR, you still need a server somewhere so that the Raspberry Pi can communicate. So you can have hosted client-side WebAssembly. So you've got the server component and then the client-side WebAssembly part. And that's what I've done. So we did that so we could get SignalR working. And SignalR is just a way of doing real-time communications between 2 points, multiple points, in fact. Created by these cool people, David Fowler and Damien Edwards. And funnily enough, it was cool because David Fowler retweeted a couple of my tweets that you'll see images of later on. So to have one of the people that created SignalR retweeting some of the stuff that I'd done, I thought was quite cool. But yeah, so it's bi-directional communications. And if you've ever done any of it, then it's most likely you've done a chat app, because that is the hello world for SignalR. So you spin up 2 windows and you can send messages between the 2 windows over SignalR, and you'll see that's where my code comes from, funnily enough, because that was the easiest way to get to a demo. It supports WebSockets at the top level. That's what it defaults to try and use, but if it can't do that, then it'll drop down automatically to server-side events and long polling. So it's quite resilient, and it's been out since 2011, so it's well battle-tested. It's a great piece of kit. So we need to drive the ARM. So if I switch over to some other code, just here, and we want, I'm going to go all the way through to, I'm going to go all the way through to the end of this, actually, back to the main. Normally I'd just step through these bits and explain it as it goes along, but it doesn't really add much value to do that. So I'm going to go right back to main, and I'll show you what I'm doing in here. So I've got a SignalR client that I've pulled in now. And this is what obviously we're going to be using to communicate to this server that's going to be running. And then before I do anything, up here outside of that main task, I'm creating a hub connection, a SignalR hub connection. So that's like the communications layer, if you will. Down here, I'm still doing the same things as I was before. Still got my 3 PWM channels that I'm creating, one of which is the software PWM channel. Start up my servos. And then here, we're going to create the connection to my PC. So I'm going to run the Blazor app on my PC here, and I'm going to then connect to it from the Raspberry Pi. That's how that's going to work. So that's why I've got this IP address in here. That's the IP address of my Pi. Now, I've had to do a little bit of jiggery-pokery because for some reason, I can't get the Raspberry Pi to trust the SignalR instance on my PC. And I've tried a bunch of things, and a few people said, oh, it's a .NET 5 thing, you need to clear certificates. And I tried all of that, and none of that worked. So I did something dangerous, in fact. It calls it dangerous. So I've just told it to accept any certificate. So that's what this part's doing just there, is just, it will connect to anything. But this is local demos. Don't do this in production, but it's perfectly fine for what we're doing there. I also pass in this with automatic reconnect, because if it loses its connection, we want it to automatically reconnect instead of having to stop and start the application. So that just makes life slightly easier for demos and things. And then we tell it to build that connection. And then next, we hook up some events. So if you remember, I said that it's the normal SignalR Hello World is a chat app, and that's exactly what I've taken this from. So we hook up to a method name, essentially, and it's all done in strings here. So if somebody says, I want you to do receive message, then I grab the user and the message that are passed in along with that call. So this would have been obviously the user in the chat and the message that they're sending, but I've usurped those, and so I've used user as the servo that I want to move, and message is the angle I want to move to. And so this is very similar to the previous piece of code, only I've converted it to an int. So I'm just moving to the angle of the servo motor that you're choosing to control, and that's the angle that I'm sending from the message. And you'll see where that comes from in a minute. And then I just write that out to the console so we can see that that's happening. And then I start the connection and then just sit there and wait. And ordinarily, of course, it would probably just stop at that point because there's nothing actually happening in the code. So I've got a while loop that just sits there and does nothing just so that this lot can happen. And then that's that same move to angle routine. So that's great. But what I haven't done is shown you the SignalR side. So if I get that on the screen, so I'll show you the main page to begin with. So this is, if I collapse this actually, this is the Blazor app. So if you create a hosted Blazor app, then you'll get a client, a server, and a shared. So client is where the pages are going to live, which I'll show you in just a second. Server is what lives on the server, and we get things like controllers in there and my chat hub that I'll show you again in a second. And then we get shared, which is where you can pass models between those two projects. We're not doing anything with shared at all for this because we're not doing anything with models. So I've got this index.razor page, which is just the home page. I close that and close that, and give me a bit more space, and close that. Then if I scroll up a little bit, don't worry about the squigglies, but I've got some controls here. So I've got this mat slider. So I'm using something called Mat Blazor, which is a free and open source collection of Blazor controls, really good. And I wanted a slider to be able to move the PWM angle. And this mat slider, the Mat Blazor mat slider, worked really well for that, and it was free. And I used that. So I bind it to a property called servo1, which is down at the bottom down there. I'll show you that in a minute. And then I put minimum value and a maximum value because I can go between 0 and 180. And nothing much else to report in the list of stuff there. And I've got 3 of them, servo1, servo2, and servo3. And then I've got a list of messages that are left over from the chat app, but we get to see what messages are being passed forwards and backwards. Then in the code, so that was the markup, the Razor markup. And then down here, the C# code for the page. We've got a hub connection, and that should look very familiar because this is exactly the same hub connection that we spin up on the Raspberry Pi. And then I've got a list of messages that are coming in. And then when the page is initialized here, then we're going to create our hub connection. Now, I don't need to pass in an IP address or anything because the hub is actually on the same machine. It's in the same project. So all I need to do is tell it where it is. And I'll show you why it's called Chat Hub in a bit, but that's what it is. And then here's that same receive message function call, if you will, message that gets sent. And we have our user and our message. And I just stick that out onto the screen so we can see what it's doing. And then we start that connection up. So it's very similar to what we did with the robot arm up here. So almost identical. We create a new hub connection and then we wire up that receive message. So obviously I'm not driving servos on the website, or rather, not literally. So there's no code in there to do anything on that other than stick it out on the screen. And then down here, I've got my properties. So this is the servo1 property that control's hooked up to. So when I change that slider, it changes that property down here. And when it does change, I send a message of send message. And I'll explain why that's not receive message in a bit. And I pass in servo1 as the user, if you will, but that's the servo I want to control. And the value here converted to a string. So it's pretty straightforward, that is. And I've got 3 of them, and I just default the values. So that's nice. Over here, we've got Chat Hub. And this is kind of the, as it name suggests, this is the hub. This is where all the messages are going to go through. And this is the function send message that you saw I was calling here. So I've got send message. So we do that again. It's by a string. So when I get that invoked, when send message is invoked, it's going to pass in the user and the message. And then I send to all the clients, I send a receive message out, and I just send on that user and that message. And so over in our code, we get that receive message over here happening. And then we dive into here and we can grab the user and the message and off you go. So that sort of closes the loop. It's not quite as simple as just obviously doing those two bits. There's a few bits of setup that you've got to do. So in startup over here, we have to add SignalR to our list of services. And we have to add an endpoint here. And this is where that chat hub endpoint that I had in the page there, up at the top, just here, that's where that comes from. So, and there's a couple of other bits, but primarily that's the two bits that you need to make sure you've done. And that's that. And that's actually running at the minute. So if I start up my code again, do a .NET run, then here is my really simple Blazor application. And here is the robot arm. And then we should know that it started up because it should just do a little dump. And in fact, it's already started. And if everything's working, there we go. I can move my robot arm with Blazor and SignalR. It's a little bit rickety, by the way, my robot arm, in that when I put it together, I missed a step. And I didn't realize I missed it until I'd finished. And I didn't want to take it all to bits to be able to fix that step. So this base is a little bit wobbly. And you see every now and again, it will just topple off because there's only a servo and gravity holding it there at the moment. So that's why it looks like it's doing that. But you can see if I sort of move that, this is the software controlled servo, and you can see it's pretty good. I'd say it's just as good as the other servos. But if you forget to put that true on the end of that software PWM definition, then it's not very good at all. So that's great. I liked that. That's basically the robot arm being controlled, but we're not finished yet. So, don't know that one. Oh, Alexa wants to get involved. Shush. Don't know where that came from. Right. So, if I go back to my slides, I'll tell you what I'll do first, actually. I'm going to stop my code because I always forget to do that. Go back to my slides. Let's talk about Uno platform. I mentioned that a couple of times. So, Uno platform is, it gives you XAML, essentially, on a Raspberry Pi, actually cross-platform on many different things. It gives you UWP. So created by Jerome Le Bon down there and a bunch of really clever people. It's based on Skia and GTK. So GTK is a graphics platform for Linux. And I've done a bit of GTK and it was horrible, actually. So to be able to do XAML, and I know some people don't like XAML either, but I quite like XAML. I've done quite a lot of WPF, so my XAML skills were quite good at that point. So to be able to do that on a Raspberry Pi is fantastic. And as I say, before that, it used to be that you needed that Windows 10 IoT image to be able to get any form of WPF or XAML on there. But now we can do that directly on the Raspberry Pi. It's not quite as straightforward. There's some stuff that you need to do to get it to work, but for the most part, you can just grab the Uno bits and do there's some templates you need to get, and then you can create a new Uno application and tell it which parts you need. And we're going to need like Skia and GTK and WPF, and there's a few bits you do need to get it to run. But for the most part, you just do that and you're off and running. But I wanted to be able to debug it and deploy it from my PC directly rather than having to do that all on the Raspberry Pi, because I like using VS Code on my PC. I know we can have VS Code on a Raspberry Pi these days, but it's not going to be as powerful as my actual PC. So I've actually got a single line install script for getting your PC set up and the Raspberry Pi set up for Uno development, so that you can do all of the remote deploying and everything. I'm not going to go into any depth on that, but it's available there. You can find it on my website. So let's have a quick look at what that looks like. So on, make sure I'm on the right page. So on here, I've actually got my Uno application, and I'm not going to dive into any detail on this, but I do just want to show you it running. So if I dial into my Pi, ding, ding, ding. This is my Raspberry Pi just there. And in fact, if I squish this to the left, and then I get the robot on the screen as well. OBS, I think it's that one. So I'll copy it from the other one. Be quicker. This one. There we go. Get those two up, so side by side. And then I've got this, so I can just press F5. And probably 1 in 5 times this just doesn't work, this demo, because I don't know why. But I did test this directly before the talk, and it did work. So hopefully we're not on X out of 5 that doesn't work. But so this compiles the project, and it targets ARM32. So obviously I'm going to compile it on my machine, and there's no good compiling it for an x64 architecture. It won't work on an ARM32 based Raspberry Pi. So there's some bits that happen in the background there. So it builds it, and then it publishes it as an ARM32 set of binaries. And then I need to transfer all of that across to the Raspberry Pi. And I use a little application called rsync and SSH to be able to then transfer the files across to the Raspberry Pi, which is what it's going to do in just a second. Of course, you run Zoom with anything, and it slows your computer down to a crawl. And that's what it's going to do in just a second. Come on, you can do it. I would have liked to have just left this running, but of course, I can't control the servos if there's already another application controlling the servos, so I can't do that. Let's give my computer a bit more bandwidth. There we go. You're still there. For some reason, I lost Zoom there for a second, but looks like you're on. So can you still see me and hear me? Yeah?
Yeah, we can still hear you, Pete.
Oh, good. That's all right then. So that took a little while. I don't know why. Sometimes it just does that. But so here's a XAML application running on the Raspberry Pi, which is nice, with virtually identical looking UI to what we had before. And I can move my robot arm using that. So if you imagine you had like one of these little or something on your Raspberry Pi, then you could have the control for a robot arm on that. And I mean, obviously, this demo is kind of it's a silly enough demo of a robot arm, but it's got real world implications. If you imagine that this could be a mechanical robot arm that you use to build cars or something, obviously you wouldn't use this control mechanism for that, but the premise still stands. So yeah, that's an Uno platform demo to do it directly on a Raspberry Pi, which I thought is worthwhile just showing that you don't need Windows 10 IoT anymore. You can do all of this net stuff as you'd expect. So that's always nice. So let's close that. And now I can close that entirely, and that can go, and that can stop. There we go, and that can go. So I've got one more demo that I want to do. But to do this, I need to modify some code in a second. So where did I get to on here? Unity. Now, I bought an Oculus Quest 2 headset, and I've always wanted to have a way of doing something in VR and interacting with something in the real world. And this gave me the perfect opportunity to do this. So obviously, as soon as you get SignalR in the mix, now I've got SignalR running there, and I've got an endpoint that I can hit. Now, if you didn't know, Unity's C#, so we can pull in those same SignalR bits and bobs and use them in a Unity application to be able to control our robot arm, and that's what I did. But I wanted to make it slightly better because I didn't want to just have my PC in the way of this. So just a bit about Unity first. So it's cross-platform and lets you create 2D and 3D apps, and supports VR headsets and C# and .NET 2 and .NET 4. It was a little bit complicated in that I just did everything in VS Code and Unity, and to get the actual packages in, I don't know if you've ever looked at what comes in a NuGet package when you download it, but you get all the different targets in the NuGet package as DLLs. Now, Unity doesn't like that. You have to get the exact right DLL from the exact right target and have it in the exact right location. So you kind of have to download them all and extract them all. So there was a bit of toing and froing so I could get that to work. But essentially, you add the NuGet packages that you need to get it to work. So VR robots. But before I do that, I scroll across to over here. I've got a Azure.
I think we've lost Pete there. We'll see if he joins back. Give him a second and see. As a filler, just until I'm hoping Pete connects back to us. But the prize draw, I've done that while Pete was talking. So if Fennoy and Reese can drop me a message in the chat, then we'll sort them prizes out after.
Something happened there. I don't know what that was about.
Yeah, just in time. Peter just finished talking about something else, so I'll let you carry on.
Yeah, I don't know what all that was about. That was weird. Right, let's put that back again. So that. So, can I get the chat to work now? Because that's what I was going to do. I don't know where you got to, but essentially anybody can go to that address now that I've just pasted in the chat, and you too can control that robot arm. And what was cool is that when I first demoed this, now this website here, Liam Gulliver and myself created for a slightly different version of this talk with a more of a DevOps angle to it. And when we gave it, one of our friends, a fellow MVP, Shahid, he'd just moved to New Zealand and he dialed in and he was able to control the robot arm from New Zealand. So, and it was in real time. There was next to no delay. It was really cool to watch that. That sort of a demo. It was, I quite liked that. So that's cool. So I'm going to leave that on this side of the screen. And while that's running, I'm going to get my VR headset and my controllers. Somebody's dialed in and they're doing it. What you'll see on my screen here is that it says please wait next to the control that's being controlled, so that more than one person can't try and control it at the same time. I get my VR headset on, which is, you know, great for demos. All right. And then I'm going to get the application up. Just there. Let that start. Normally what happens is while I'm doing this, somebody controls the robot and it falls over. So I have to keep checking that it's not fallen over. Right, and then I can do cast, and I can cast to my computer. And then you should see, there we are. Now, so what you should be able to see is that if somebody moves the robot arm, you should see it move in virtual reality. And you should see the real one move as well. And likewise, I can move it while somebody else is moving it. And you can see the grab. Funnily enough, I think I broke the grab in the last time I modified the software. But if somebody else moves the grab one, then you'll see the grab. There you are, look, so you can see the grab move in real time there as well. So you see, it's just about as wobbly in VR as it is in real life as well. But essentially, this is the same code. Obviously, the robot part itself isn't. I've had to do some work to get the robot to look, you know, like a robot. But all of this control code is the same sort of control code that we've got everywhere else in the Uno app and in the Blazor app. So this is the demo that I tweeted out, and David Fowler was retweeting. So I was quite happy with that. Oh, it's not fallen over yet. I'm amazed. So yeah, so that's the demos mainly. So I'll just close that down, and I'll go back to I'll leave it running so people can have a little fiddle still. But just some links here. So you can go to that GitHub there, .NET 5 Robot Arm repo. Don't worry about noting all of these down. I've uploaded the slides, so you'll see in a few slides' time there's a link to that directly. Some information about .NET 5 and installing .NET 5 on a Pi, and then the GPIO and device binding source code. And then there's the 3D printed robot arm that I'm using. And then there's the one that Cliff Aegis has made, which is way simpler to assemble than the one I've used here. And I recommend that you use that one instead. And I think like yours, I've put the zoom on like a completely different page, so you're all the way over there. And then there's some information about Blazor there, and Matt Blazor and Awesome Blazor is another great selection of tools. And then some information about SignalR and the Uno platform. And then if you're interested in .NET and NOTS IoT, we do sort of Microsoft often, but we've got Andrei Podnosov coming along to talk about Azure Digital Twins. And then at .NET NOTS, we've got lightning talks. So if you want to come along and give a talk, then by all means get in touch. There's if you go to our website, rather the meetup group, then there's a form on there that you can fill in to come along and speak. You're more than welcome. I also, along with Cliff Aegis, run a Twitch show called IoT Live, and we're on the Azure-ish Live Twitch channel there, so you can check that out. And if you want to learn a little bit more professionally about IoT, then I'm a Pluralsight author, and I've created a bunch of Pluralsight courses aimed towards the AZ220 Microsoft certification. So you can check that out. And that's about it. And you can contact me at any one of these places, but the slides for this deck are at that bit.ly at the bottom of the screen. So while that's happening, I'm going to bring you onto here so I can see you on every screen, because I can't see you at all at the minute. Right, and then I can go back again, and then you can still see me, and I can see you. Good. There you go. So that's the end of that talk. So thank you very much for listening along.
Thanks, Pete. That's the first time I've actually been able to see that all the way through, to be honest. I've seen most of the parts of it in separate talks, but never actually got the whole thing. So I think the most I got was DDD. You did this, not quite. I don't think you got the Uno platform part, possibly, and the Occulus at the DDD when I managed watch along last time. But
Uh-huh.
I had to nip out early just before the end of that one. So yeah, and like I was saying about how busy Pete is, this slide that you're sharing now just shows how I don't know how you fit it in. I really don't.
Yeah, I like to keep busy. I'm a member of a podcast, the Agile Engineering Podcast, with Liam Gulliver, Jonathan Rolfe, Misha Bell, and Louise Paling as well. We do Azure-ish Live, Jonathan Rolfe and Liam Gulliver and myself. I'm a member of another group called Lati in Loughborough. It's like a high-tech networking group. The network, Not Dev Workshop, dotNET Knots, Knots IoT, and then the work and family life on top of that. Yeah, keeps me busy.
Yeah, as well as doing these talks and for other groups and conference talks when the conferences come back around, like you said.
Yeah, exactly.
Very busy man.
Good. Yeah, thank you for having me. It's good. I enjoy that talk. I've given it so many times now that it sort of just rolls off the tongue, and I always enjoy the quest stuff. I wish I had more time to spend making stuff like that. I was quite enjoyed figuring out how to use Unity. That was cool. So obviously, if anyone's got any questions, then by all means, just take yourselves off mute and ask what you like, and I'll attempt to answer it. And if not, then I'll say hit me up on Twitter or via email there, and I'll happily answer questions that way too. Yeah, there you go.
No, you must have done a good job at explaining everything. That's all I can say.
Yeah, that must be it. Cool. So, did you say you were going to do a prize draw?
Yeah, I did. I announced that while you were when you disappeared, just as to fill the gap. So
happy days! Congrats to whoever won whatever they won.
Yeah.
Excellent stuff. Cool. Yeah, there you go.
Yeah. Does anyone have anything else then, or does anyone have anything else for share? Not related to Pete's talk, or questions for Pete, or?
Oh, very quiet tonight. Oh,
No,
there's something in the chat. Let's have a look. Great talk, Pete. Thanks. Yeah, I think I recognise you, William. I recognise your name, so I'm assuming it's the same William Townsend that I already know. Thank you.
Quick question.
Yeah, go ahead.
So, thanks a lot for your talk. Was that all 32-bit then?
Yeah, so everything running on the Pi there will be 32-bit. Although recently there is an Ubuntu 64-bit flavour.
Yeah, which I've got. Yeah.
There you go then. Yeah, which I've not played with, yet. I've not really felt the need, but there's an issue with my script in that it'll pull down the 32-bit version. By the way, so bear that in mind if you run that script, then it may not work on your Ubuntu 64. That's another bit of work that I need to do. Is to determine that. You can do it because there's just a command that you can call to figure out what sort of flavor of an operating system you're running. So I'm sure I can add that to the script. It wouldn't be a massive job. It just means burning a 64-bit Ubuntu image and trying it out. But I'm not sure if though with the 64-bit ARM, if you can just do a sudo apt-get. Because I've got a feeling that there might be a sudo apt-get for 64-bit, but not for 32-bit. So it might be worth checking that out.
Okay, thanks. Yeah, I've got 64-bit, and I could possibly try it out for you if you. If it's a diversion, then.
No. Always no. If you try it out, then definitely send me a tweet and tell me what you got to. And obviously, I know my script, as I say, that probably won't work. But if you can find, I think it just gives you it somewhere. I think if you go to the .NET 5 page. Let's just do it here. I've got a feeling it tells you to do it on here. Somewhere. Package manager, I think it's that, isn't it?
Yeah.
So manual installation, blah, blah, blah. CentOS, Debian. So what's good about, by the way, what's good about this is that they, as part of their regular testing, they test to make sure this works on a Pi. I'm guessing they must use my script, but because they're apt-get, as I said. Don't see it on there. Demi's apt. No command written on there, but I think you might find that.
The app just works it out.
Yeah.
Yeah.
Yeah, I think there'll be a way of doing it. I've not tried it yet, but yeah, look. So even this is telling you how you need to go about doing all this to get it installed properly for the different versions there. And even that's not as straightforward because they've missed out some linking steps to do in there. But yeah.
Okay. Thank you very much.
No worries. Yeah, ARM 32, ARM 64. And then some others. Oh, yeah, it's going to download it now, look. Okay, cool. There you go. So that's that. Yeah, I need to try it. So yeah, if you figure it out, then let me know. Send me a tweet. Right, what else was in there? Great to get an intro to RPIoT. Not looked at that before. Cheers. Thank you, Chris. Reese, thanks for the talk. Very useful information. I just bought my third RPi. Great. Yeah, that's so. Hopefully, most of you have got Raspberry Pis, and hopefully they're not going to live in a drawer anymore. I've given you some impetus to go and pull them out of the drawer. Do you only do stuff with Raspberry Pi Pico, or do you use Arduino as well? Yes, I do. So I've done a project just recently with the ESP32, monitoring solar home power units in Africa, as it happens. So a company came to me and they didn't have the cloud networking side of things down. So they'd created a nice board with an ESP32 in it and some software. And actually, for saying the guy had done it, wasn't a programmer, he'd done a fantastic job of getting it like reading sensors and storing stuff and showing stuff on a screen. He'd followed a lot of tutorials, he said, but he'd done a good job. But he had no way of getting that data out anywhere. And, you know, if you've got an ESP32 sitting in the middle of the savannah in India or Africa or whatever, then you can't really get that data out by telling somebody to go and get it off the SD card. So the ESP32 has got a GSM module on it. It's a really basic 2G modem, essentially, that you have to fire AT commands at. But I created an Azure function that this can control. The ESP32 over GSM connects to the Azure function, and then that hooked itself up to IoT Central. I quite like IoT Central, software as a service offering from Microsoft that lets you ingest IoT data and then stick graphs on the screen and control devices and stuff. And that was perfect for him because I could create the solution for him and then leave him with it. And Microsoft would essentially maintain it for him. All he needed to do was just add the new devices when he needed them, and it gives you all that facility. So that's a pretty cool little project, that one is. I quite like that. So yeah, Arduino. I've got a talk that I've not done in a while now, which is about IoT with nothing but your laptop. And there's a bunch of simulators out there for Raspberry Pi and for Arduinos and Microbits, another great little IoT learning platform. But there's web simulators out there for all of them. But what's great is you're not stuck in those web simulators. You can download the code for the most part onto a real device. So as part of that talk, I go all the way through that and then show like servos working on real devices. Not too dissimilar to what I'm doing here, but slightly more top level down. So yes. I've still got to find time to try .NET on a Pi. There's another, you can do .NET on embedded things like Arduino to a degree with the Meadow. So Wilderness Labs have made a full .NET compliant, I think it's .NET Standard 2.0, I think it is, compliant device, Meadow F7 board. I've got a box, a hack kit in behind me. Funnily enough, on our Azure-ish Live, we had Brian Kostanich, who was one of the guys who created it, ex-Xamarin Microsoft guy, on, and he was explaining how that all worked. So if Arduino type microcontroller based .NET is what you want, then definitely check the Meadow out. That's a fantastic device. Slightly more expensive, it's about 30 quid, but it's really powerful and constantly being developed as well. So definitely check that one out. Played around with Arduino in the past, but never done anything with it on the Pi. Definitely give that a run. Good stuff. I got 4 in the drawer. Yeah. Oh, you got two 4s and an 8 gig. Crikey. Yeah. Definitely make something up with those. Thank you. And is Arduino talk videoed anyway? Yes. Let me see if I can find that. It's be on my YouTube channel somewhere. I'll just pop a link in the thing. It's quite a fun talk. It's not. It doesn't take itself very seriously, that particular talk. Playlists. And then my talks. Just going to start me speaking probably. No, there we are. IoT with nothing but your laptop. .NET Chef, that was a good enough one. That one is. So I'll paste the link in there. There you go. So you can check that out. So it's quite a fun talk, that one is. So yeah, check that out. Quite handy. And obviously you can check my my playlist of all my talks out there. I think it's public anyway, so if you wanted to, then you can see. Shush. Speaking to myself. There's loads of stuff on there that I've been involved in doing. But yeah, it's good. This is quite a cool talk, a short history of IoT. It's actually not a short history at all, but there's quite a few science experiments in that talk. If you get some time, watch that. It's quite interesting. I go all the way back to the telegraph, and I made a telegraph, and I made a rudimentary telephone as well. So the same sort of telephone that Graham Bell would have made. And I explain how that history works, and I talk about magnetism and that sort of stuff. So that's quite a different, entirely different sort of talk. I've only ever given that talk once, but yeah, it's quite cool and worth watching. So there you go. I've waffled.
Yeah, very interesting information though. So I think it's worthwhile just extracting bits of knowledge from me. That's what it is.
Good. Yeah. So, and obviously, what's your talk that you're going to do at DDD? Do you mind telling me what that's going to be?
I meant to say, I don't know. It's meant to be.
You can tell me broadly what the area is. You don't have to tell me the talk title or anything.
So it's around WSL.
Okay, cool.
I have done that talk at dotNET Stoke a couple of months ago.
Right.
All very similar. And I've done it at another meetup as well. So
cool.
It's been tested a little bit. But I'm not a natural speaker either. So I'm out of my comfort zone speaking at just these. So, but I definitely want to try and push myself a bit more in that area. So.
Yeah, well, you'd be more than welcome at .NET Knots. Come and give that. I mean, we're not going to be back to in person in a while either, anyway. So I think we've got some space later in the year. So you're more than welcome to come along and speak at that. Be happy to.
Yeah, I was hoping to do it. To be honest, I was hoping to do it once a month. That was always the original plan this year, and that was like a goal. But I did the first couple of months, but the requests, I don't know whether I should be going out and asking to do it at groups or whether you wait to be approached. So like I say, it's something I'm new at. So the more that you're out there, I guess, the more that you'll get requests. But while I'm fairly new, I've got to try and seek it out a little bit more. So
yeah, no, I think all of us organisers, I mean, you're one, are happy when people send us a tweet or an email to say, I've got this talk, I want to come and do it, because it saves us doing that job of going and finding somebody. So, and certainly if you've got a recording of it, that sometimes helps if you are brand spanking new. But I just wouldn't tell people that. I don't think it's relevant. If you've got a talk and you want to give it, then send an email or a tweet to people and they'll be happy. As I say, we're more than happy to have you along and speak about WSL. I like WSL.
Yeah, I mean, let me know then. I've got one in August lined up, I think, that I was meant to do last month or the month before, and then they got two organisers and one had filled the spot whilst I was in communication talking to the other one.
Oh, really?
So I ended up being bumped to later in the year. So, but yeah, I'm happy for come and speak and return the favour, I guess.
Yeah, exactly. Well, we've got space August, September, October, November. So you probably wouldn't want to do it in October, because chances are you might be doing it in DDD.
Yeah.
So doing 2 NOTS events one after another probably wouldn't be ideal. So it kind of feels like you might want to wait either way and see what happens with your DDD talk.
Yeah, I'll get in touch. I'll find out whether it's selected for DDD.
Yeah,
and
I
then
think it's going to be a week or so before we find, maybe 2 weeks, I think, because I think those dates that you showed on DDD website have been pushed back, because I think Jess has added an extra week to that.
right.
Because I know the CFP got pushed back a week. So what's that? CFP closes. Yeah, that finished, I think, this Friday just gone. So maybe it wasn't then. When was it? What was Friday? Friday the 3rd? No, it isn't. No, it is that is it. So voting opens 21st. Voting closes 4th of June. Agenda published 3rd of September. I don't know if you'll find out in between those 2 dates or on that date. I can't tell you that.
Yeah.
So you might not know, but we can put you down anyway. Doesn't matter.
Yeah. I could. Yeah. I'll speak to you after then, and we'll sort something out. So I'll drop you a message tomorrow or something.
Yeah,
and
perfect.
just get back to us.
Yeah, I like it. Good stuff. Of course, we get GUI now, don't we, in WSL, in the latest WSL 2. We should get front end stuff in there. And I think I saw somebody who'd ran the calculator app that had been ported to Uno platform in WSL or something like that. Done that, which I quite liked. So yeah, just click the calculator in your Windows menu bar, off you go. Yeah, that was quite cool. Inception.
Yeah, with the GUI, it'll open so many possibilities. It's I mean, there's a lot of possibilities just with the without the GUI, especially in terms of development, because you can go and try and test and debug through your apps and stuff if they're going to live on Linux server. Ultimately, you can run them natively or as good as natively.
Yeah, exactly.
So it's there's possibilities already, but introduce the GUI and people are more comfortable, especially if you can with all the cross-platform now, like Uno platform, and yeah, it'll allow even more for testing. So.
Yeah, it's good. And things like IoT Edge as well, if we're talking IoT, then there's something called eFlow, which uses WSL2 to be able to run IoT Edge runtimes on Windows, because they're native Linux normally. So eFlow lets you lets you run and debug those on your Windows machine, again using that WSL2 tech, which it's pretty handy. So I'll tell you what I'll do as well before I forget, is I'll just stick the link to the links to the slides in the chat so people can have those should they want them. Oh God, everything's all gone wrong. Everything's gone on the wrong screen for me. Where is it? There we are. Jeez. I've got multiple desktops all set up to be able to switch between the various bits of that talk. It just makes life a lot easier because I know where I am. But then when Zoom crashed, it put things on a couple of the different desktops. Got the main windows on one window and the other one's on a different. So confusing. There we are. That should fix that. So yeah, that's better. Cool. So there you go. All right. Well, I think I'm going to call it a night. I'm going to go and see the rest of the family before I've got another blooming meeting at 9 o'clock tonight, of all things, with a company in Seattle talking about IoT. JetBrains Tools is the killer feature for me in WSL2. What is that? What does that do?
So I've got a bugbear. Sean knows I like WSL. Anyway, I'm a consultant, and there's so many places that I go to that they insist on developing in Windows, but all the software's running in Linux servers, and I'm like, well, why are you fighting with like bash scripts and line endings and all this thing, all of this for me, crazy stuff. But then I love JetBrains stuff. If I've got to do Java or .NET or all that stuff. I just like the JetBrains kit, but it can't run on WS2 on WSL too well,
Okay. Right.
especially Rider and those sort of things. So then, once I get a UI, then problem solved.
Yeah. Beautiful.
So yeah, so I can just write software native, away I go. So yeah, I've been waiting for that for ages.
We had somebody from JetBrains, I can't remember what her name was now, at dotNET not speaking, and I seem to remember her talking about that briefly, about Linux support, and yeah, I can't remember what she would have said. That'll be recorded there somewhere on the dotNET Not's YouTube channel, that talk.
Yeah, well, they've just launched something called Projector,
Okay.
which is, for the want of a better description, it's a VNC server, I suppose.
Right.
But it's like brand new and like really, really raw. But that runs the UI on the, I'm going to call it on the server side or on the Linux side, and then you connect to it. So, but yeah, it was flaky when I tried it. So yeah.
That's a shame. That was that talk in the chat there by
Okay.
Rachel Appel, her name was, and it was about what JetBrains are doing behind the scenes actually, but obviously there was a whole heap of Q&A at the end, so you might find scanning through that might answer some of your questions there on roadmaps and stuff.
Oh yeah, but as soon as Microsoft launch this, I'm away. So yeah, but I don't want to use Insider yet. So has anybody got any ideas, Sean?
Of a time frame?
Yeah,
I don't think that I'm not sure if it's fully being supported in H1, the H1 release, which is due next month.
Yeah.
No, maybe this month now. It was due May, but whether it lands in May, they haven't hit the last couple of deadlines, like release schedules. Microsoft haven't, so it might end up being June, but I'm not sure if it is completely ready. I thought it was coming in H2, to be honest, but I know that there's definitely more and more stuff I'm seeing online. It's not something I've played with yet, so for the same reason, I've not got an insider's build, so I haven't had a chance to have a crack it open myself yet. But whenever I get the next talk scheduled, it will definitely be something that I'll have to look at getting set up and trying to.
Yeah.
What you were saying about the JetBrains, that projector, if that's relatively new as well, JetBrains have a habit of throwing their apps out before they're actually ready as well. So just to get them out there, I mean, it's not the wrong way for do it, I guess, as long as people are aware and not paying for the product and getting rubbish. But I know that Rider was like that for a while, that Rider wasn't really up to scratch when they initially threw it out there to everyone. So
but see, I can't take the risk because I need to work. So I'm like, okay. And when I spun up a projector, I think it took 12 gig of RAM and just bought down the machine. So I was like, okay, delete. That's gone. Next.
12 gig of RAM. Oh.
Yeah. So some of their stuff does work with OWSL, but Rider doesn't yet, and I don't think IntelliJ does yet. So it'll come. Patience.
Yes. Yeah, patience in one.
Yeah.
Cool. Right, hanging the jet off, but on the jet. Thank you very much for having me. Again, hit me up on Twitter if you've got any questions or if you need any more information. And yeah, I'll see you all again soon.
Yeah, thanks again, Pete.
No worries.
Thank you very much.
See you later.
Bye-bye.
Bye.
Hi, Sean. Nice to see you, mate.
Yeah, and you. I got your LinkedIn message. I'm going to drop you an email when I get chance. It's just been busy.
No rush, mate.
But I'm gonna catch up and have a chat at some point. So.
Yep, definitely, mate. Definitely. And if you take too long, I might just be in Stoke by then.
Yeah, is that on the cards now? Then is it? That was yeah.
Yeah.
Yeah. Well, to link to that, I'm gonna start looking at these in person potentially as well. So I don't know what kind of audience that we'll get, but if you're interested coming along, obviously it won't be the next day or two, like next month or two.
No. Yeah.
I mean, but like it, hopefully before Christmas, especially if these in-person conferences get up and running in October-ish time.
Yeah.
And I'm hoping for November, December to get one or two of these under his belts, just for
Well,
for another catch up. So if you're up here, that'd be great. Like so.
I don't know yet, mate, when,
Yeah.
but I know it's on the horizon.
Yeah.
I've just taken off a week. I'm just painting and decorating here to
Spruce it up a bit.
That's it.
Yeah.
So yeah.
That's good news then. That'll be nice for have a proper catch up then when it's back up here. So yeah. Well, like I say, I'll drop you a message when things have quietened down a bit. And,
brilliant. Okay then, mate.
Yeah. All right, and I'll speak to you soon then, Neil.
Thanks very much. Bye
See
bye,
you, everyone.
Bye bye.
Bye.